Hello Internet. Today I'd like to go over the construction of my prosthetic hand that I've been doing as a side project. So firstly we're going to have a look at the mechanics. Alright, so in terms of the mechanics, normally this lid is screwed on in 4 places. The lid itself is just glued together, 2 3D printed pieces. It's designed to be printed upright, no supports. Inside the hand we've got 2 main parts, the body and the fingers here. Now we'll probably start with body, that's the simplest. That's just a nice shell. It's got this motor holder here in it. It's got some holes. There's a hole here to help you with assembly. And then these finger stubs here which leads to the fingers. Now mechanically the fingers have 3 joints with a piece of elastic going through the top. It's just elastic cord, and to the other side here, be able to see in there. The joints are actually just 3mm holes with 3mm 3D printer filament pushed through. You can see here, and that works really well actually. It's quite easy assembly, and the elastic keeps the finger straight. So this elastic goes over the top of the pin joint, and then below it is another hole all the way through the finger with fishing line. These fishing lines go all the way through, and they all connect at a central nut here which has been got glue on it to stop the fishing line from slipping. We have the 4 or 5 fishing line connect to the nut, connected to another piece of fishing line. This is braided fishing line. It has to be braided to be stronger because this has 5 times the force of these fishing line here. That goes into a pulley which is connected to a coupling which is connected to the shaft of a high power worm gear drive motor. This is a 12 volt DC worm gear drive that runs at 30 RPM, but we're actually running it at 24 volts to get more power. And as you'll see at the end, this gives the hand a lot of grip, including the rubber fingertips it's got on it. It performs really well. Now that's probably all the mechanics. I guess we'll go and have a look at the electronics now and how the electronic circuit works. Alright, so picking back up the electronics, you can see that we've got the 2 wires from the motor that come and wrap around here, and these go into the PWM driver. This motor driver here is controlled by PWM signals that come from the Arduino, but it actually takes its power straight from the 24 volts. So this motor is running the 24 volts. So this is a 24 volt battery, by the way. Nice small compact 24 volts, 600 milliamp hour. So the 24 volts comes into the circuit here. 24 volts goes to the driver, but we also have a 5 volt regulator here, and that regulates power for the Arduino, and the Arduino also gives that 5 volts in the form of PWM to the motor driver. Now to control the whole circuit, we have a on-off switch here which just literally switches the battery completely on, completely off. And we also have this force sensing resistor which talks to the Arduino. So when this is used in combination with a pull down resistor, so when you press this, the Arduino knows to close and open the hand. Alright, and now in terms of its actual operation, what happens is, to keep everything in sync, when it turns on, it'll fully close the hand as far as it can go, and then it closes on a timing sequence, so it just knows how long it takes to close. So if the hand is stopped before that, it'll just keep trying to close, and then what will happen is the motor driver will switch off power completely to the motor, but because it's a worm gear drive, it will actually hold that tension. And then what happens is, in the opening sequence, it then opens the correct amount to be fully open, so the pulley will be sitting at the right spot, and then these elastics will hold the fingers straight out. So I'll just show you that now. the thumb right now, the elastic's not strong enough to pull it back, so you'll just see the thumb hanging around. But yeah, that should be easy to fix. And I'll just show you that again with holding the fingers closed. Oh, open, sorry. Yep. And then just each time I press it, just goes in and out. And the reason it will never go out of sync is because it closes for about twice as long as it takes to as the timing for it to open. So it'll always get to a point where it's just stopped and forced, and then it will just release and you press it again. But yeah, the beauty of this system is it requires no power to hold this grip now. Yeah, so I'll just show you picking up this speaker here. And yep, now it's locked on, that's it. It just requires no power to hold this all day, which is just the beauty of the worm gear drive. It won't be driven backwards. It can only be driven from the input, which is only controlled by the electronics. To drop it, just hit this button, and we're good. And just one thing I wanted to mention with the force sensing resistor, you'll see me holding the hand and touching it like this to use the hand. But in actual fact, if this was used in a real prosthetic, the goal would be to move as much of this electronics and motor up into the hand to leave space for another piece, which would be basically the interface between the plastic hand and the person using the prosthetic. And this would slip between that plastic interface and their arm, and the hand would actually be controlled by them flexing their forearm muscle, which would put pressure on this, and you can see it's very sensitive, and that would operate the hand. So it would be very natural control. And I'll just give you a close-up of the fishing line closing. And that just holds that, and then yeah, so it's turned out to be a very reliable system. I'm very happy with it. The last thing to go over is the software, so we'll have a look at that, and then I'll give you some things I would improve for the hand, and if I made another version. Alright, we'll just go over the code now. It's only 80 lines, nice and simple code. We have 3 defines here to define our pins. We have a FSR amplitude define, which determines how much force is needed when you press the force sensing resistor to close the hand. We've got how long it takes to open the hand, how long it takes to close, and the strength of the hand, which is integer from 0 to 255. So it's currently set at the maximum strength, which you could set to any strength you like. We've got our functions here and a ball that tracks whether the hand is open or closed at the moment. So in the setup, we set our 2 motors to low just to start the process, and then we close the hand, and then we open the hand, and that's part of the calibration process. In the loop here, we read the value of the force sensing resistor. We take that to a function that determines basically whether the force sensing resistor is lower or greater than the amplitude that we set here. That's why it's called to digital, because it just converts this analog signal to a 0 or a 1, depending on which amplitude you put in, and you can see that here. And then if the FSR value is greater than the amplitude that you set here, it will move the hand. Now, what does move the hand do? Very simple function. If the hand is open, we close the hand. If the hand is not open, then we must open it. To open and close the hand, I guess this is where the meat of the code is. All you have to do is analog right to whichever motor is the pin that gives you the open direction. You open it with full strength. You have to wait for the time to open, and this will continue to open the motor during the delay. And then you set the motor low, and then you tell the hand that it is in fact open. And close hand is very similar, except it's the other pin, and it's time to close, and then you have to tell the hand is closed. Yeah, so very simple code, that's all actually. Alright, I hope that little walkthrough was informative. I'm just going to go over some things I would change now. This is the second version of the hand I've made, but if I was to make another one, which I probably won't, I probably would, a few things I would just optimize a little bit. See the fingers bend back a bit. It's because I gave the joints a bit of a tolerance, because I thought that the fit wouldn't wouldn't be so good, I guess, but it turns out they actually bend up a bit, and that's kind of annoying to look at. Another thing I would change is I would make the thumb actually opposable. We can see here that the thumb is at a 90-degree angle, and that just, I'll turn it on. That affects its gripping capability, because you can see that it's not quite, you can see it doesn't quite really clamp down on the fingers with the thumb like you would when you hold something. So that's definitely an area of improvement. Another thing I would fix is just making the battery bay bigger. See, if these were just rounded out to be circles, this would actually be able to close, but it's not able to at the moment. And the reason they started flat is because the original printing orientation was like this, but I worked out that it's way better to print stuff like this, so that required a bit of a hack to get working, but if I was to do it again, I would just design it from the ground up to be printed on its standing up. And that's pretty much the main things I would improve. And I guess another big thing would be to try and shorten the overall length of the fingers and the hand itself to attach an interface, which would just be attached through screws probably to this back here, which could actually join onto someone's hand to be a useful prosthetic. So it would be kind of cool if I ever want to pursue that. Yeah, now I'll just throw to some clips of it picking some stuff up. I think it turned out really well. I hope you liked it, and please give me a subscribe if you want to see more content like this. Yeah, that's all. See ya.